This is 5.2, adding and subtracting polynomials. We're going to identify the degrees and leading coefficients of polynomials and add and subtract polynomials using horizontal and vertical methods. So what's a polynomial? Well, it's an expression of the form ax to the nth power plus or minus bx squared plus or minus cx plus or minus d. Okay, so you've seen these before when we do combining like terms. You might have, let's use numbers, 5x to the fourth power minus 3x squared plus x minus 7. That's a polynomial. Okay, so A, B, C, and D, those all represent your numbers in front of your variables, your coefficients, and then you have your variable x, and then you have powers or exponents. Okay, the polynomial is of degree n, so the highest exponent is the degree. So n, whatever the highest exponent is, that's called our degree. Our leading coefficient is a, so the coefficient on that highest exponent. So a is important because it's the leading coefficient. Then we have our constant d. That's the term without a variable. So d would be our constant here. In this case, it would be -7. 5 would be our leading coefficient, and 4 would be our degree. And a polynomial is in standard form if it's written from highest to lowest power. Okay, so I wrote mine in standard form because this exponent is 4, the next highest would be 2, the next highest would be 1 here, and then this is x to the 0 power, because remember x to the 0 power is 1, so we don't need to write 7 times 1, we can just write -7. So let's determine some of those degrees and leading coefficients so you can kind of get a feel for it. But first, one important thing I want to mention is a polynomial with only one term is called a monomial. You'll hear me say that often. And another word that you'll hear me say even more often is a polynomial with two terms is called a binomial. And 3 terms, you probably guessed it, a trinomial. Okay, so monomial, binomial, and trinomial. These two we'll deal a lot with in the upcoming sections. Okay, so let's plop down here. We're given a polynomial, 5x squared minus 2x to the 7th plus 4 minus 2x. I want to write it in standard form, which means I'm going to find my highest exponent, not 2, but 7. And I'm going to write that term in the first, first. One important thing is that this negative sign is on the 2. So I need to make sure I keep it there and write negative 2x to the 7th. Next highest power would be 5x squared, and there's a positive sign in front of it. So I want to write plus 5x squared. And then I have a 4 and a negative 2x left, so the first power comes before x to the 0 power. So I'm going to write minus 2x and then 4. So that's in standard form. Now let's pick out the degree. Remember, the degree is the highest exponent, so the degree on this polynomial would be 7. The leading coefficient is the number in front of that highest exponent. It's the coefficient in front in our standard form, so that leading coefficient is -2. Okay, I'd like you to try the second one, 16 plus x cubed. Put it in standard form, find the degree and the leading coefficient. Okay, hopefully you put it in standard form and we're able to see that x cubed comes first and then 16 comes second. The degree would be 3, that's the power on the highest power, and then the leading coefficient, the number in front of our variable with the degree, that's a 1. There's a 1x there, it's not a 0. So make sure your leading coefficient, you put 1. Okay, and let's look at the last one. If I were to put 10 in standard form, this is a polynomial. Okay, think of it as 10x to the 0 power. It'd be a monomial, it's only one term. So in standard form, it's just a 10, there's only one thing there. The degree on that, what is the power of x? That would be 0. And what is the leading coefficient? What's the number in front? That'd be a 10. Okay, so that one was a little trickier, but I do want to show you it. All right, We're going to be adding and subtracting polynomials in this section like the title says. So let's talk about the horizontal way to add first. And addition of polynomials is not like multiplying and dividing. Okay, so think of addition as combining like terms. So here's our first polynomial, and we're adding it with the second one. Okay, so I'm adding each and every one of these. So I'm adding an x squared. I'm adding a positive x, and I'm adding a positive 6. Okay, so I can get rid of the parentheses in addition. And from there in the horizontal method, we've done this before, but you just combine like terms. So a term has to have the same variable with the same exponent. So this variable is x, and this exponent is 3. Do I have any other x cubes? No, I don't. So then I go on to my next one, x squared. Do I have any other x squares? Oh, there's one. And I always want to make sure I circle the sign in front, so I remember if it's a negative or it's a positive. Okay, and then I have my my constant. It doesn't have a variable. Do I have any other numbers without a variable? I give those a different shape. And x is by itself, so I won't have anything to combine them with. So from there, I have a 2x cubed. I'm going to combine my circles. X squared plus x squared is 2x squares. It is not x to the 4th. All right, I'm simply adding their coefficients. 1x squared plus another x squared is 2x squareds. I'm going to put this in standard form, so the x needs to come first. So I'm going to write plus x, and then a negative 5 and a positive 6 make 1. And my final answer. Horizontal method, or that's the horizontal method. This is the vertical method. It's another way to do it, but you could also certainly do it the horizontal method. So this is just a preference thing. I'm showing you 2 different ways, and you get to decide which way you like best. All right, so I want to start by, I'm just going to write my first polynomial here. And I'm going to add vertically now. I'm going to write my second polynomial, and I want to make sure I line up my powers. So I need to put my 3x squared in the x squared column, my minus 4x with the other x, and then the plus 7. And then I have one more that I'm adding, a negative 3x cubed, so I'm going to put that in the x cubed. My 4x squared and my minus 8 will go down here. So now I'm just adding my columns, right? So I'm combining like terms. It's like I've collected them all. So let's do our x cubes. So 5 plus a negative 1 would be 4 x cubes. 2 plus 3 plus 4 would be 9 x squares. A negative 1 and a negative 4 would be negative 5 x's. And let's combine our constant. 7 plus 7 minus 8 would be a positive 6. Okay, so we have our vertical method and our horizontal method, but it's doing the same thing, right? I'm just combining my like terms and then adding them vertically. Combining my like terms just in a different style, right? Let's talk about subtracting polynomials, because subtracting can trick people. Subtracting means add the opposite. Okay, so what you could do is change this to addition and change all of these signs. It means add the opposite of whatever's there. The other way that I think about it is just distribute. Distribute that negative, because you are subtracting not just this first term, but you're subtracting that first term, you're subtracting the second term, you're subtracting the third, and you're subtracting the fourth. You're subtracting this whole entire thing in parentheses. All right, so let's distribute our negative. Our first polynomial is going to stay the same. I'm going to get rid of these parentheses, and I'm subtracting x cubed. I'm subtracting 2x squared. I'm subtracting a negative x, so that will change positive, and subtracting a negative 4, so that one's going to change positive. And now I can just combine like terms, right? Horizontally, I have my cubes, so find all your cubes and box in the sign in front of it. Find all your squares, you can circle them in, sure you circle in the sign in front of it. You have your x by itself, and then give your last shape to your constants. So combine your rectangles. 3x cubed minus x cubed is 2x cubed. Then we have a negative 5x squared minus 2, so I'm at negative 7x squared. I have my x, my lonesome x, and my triangles, 3 plus 4 would be 7. So please don't forget on subtraction that you're subtracting all of it and to change those signs. Okay, let's look at the vertical method. So it means the same thing. You don't have to do it this way. You can still distribute and do it the horizontal method. I'm just going to show you one more way to do it. So 4x to the fourth minus 2x cubed plus 5x squared minus x plus 8. That's my first polynomial. And I'm subtracting this polynomial. So I can write subtraction and I could copy that all down. But, I want to make sure I line things up here. If you write subtraction, don't forget that you're subtracting each and every one of them. So what I might recommend you doing is, again, subtraction means add the opposite. So I would write addition and kind of already distribute that negative when you're writing it vertically. Okay, so I'm going to add the opposite of whatever's in my parentheses. So a negative 3x to the fourth. Opposite of negative 2x cubed would be positive 2x cubed. Opposite of 3x would be negative 3x. And opposite of negative 4 would be positive 4. That way I just know that I'm adding and I have the sign right there in front of me. But you can certainly do it the other two ways. So a 4 plus a negative 3 would be a 1x to the fourth. And again, I have the space here because I had no x squared term. I have a negative 2 plus a 2x cubed. That means there's no more. They canceled out. There's no more x to the third, so you could put 0x to the third, but I really wouldn't because what a sign would probably count you wrong because there's no more x cubed terms. They're gone. 5x squared plus 0x squared means I still have 5x squared there. Don't get rid of him. I have a negative 1x and then minus 3 more, so I'm at negative 4x, and 8 and 4 are both positive and they make 12. So x to the fourth plus 5x squared minus 4x plus 12 would be my final answer. All right, combining polynomials. What we really need to work or be careful of here is our grouping symbols and our addition and subtraction signs. So I want to make sure, I'm going to do this a horizontal method. I want to make sure that I be careful on subtraction, so I'm going to go ahead and distribute that right away. I'm going to get my pen a little bit smaller because I don't have much space. So negative 4x squared, I'm distributing the negative to the 5x, I'm distributing the negative to the negative 1, so it turns positive. And then I'm just going to drop down my addition of all of these, right? Addition means they're going to stay the same, so you don't really have to distribute that, but you can. And now I'm just going to go and combine some like terms here. So I'm going to box in or circle or whatever shape you want to give to your x squares. And combine them. So a 2, a negative 4, and a negative 1 would be negative 3 x squares. Go ahead and do a different shape for your x's. So negative 7, negative 5, and 4. You'd be at negative 8x. And then lastly, 2 and 1 is 3, plus 4 would be 7. Okay, here we have a polynomial in parentheses, and we're subtracting these two polynomials, but they're in brackets, okay? And so you need to do the brackets first, just like any old grouping problem, right? Like if this was a number 4 and you're subtracting 7 minus 2, okay, so that represents a number, this represents 7, and this represents 2. I'm doing the exact same thing, just with numbers. I'm demonstrating this for you. You're going to get something different if you take 4 minus 7 first. Okay, so you have to do these groupings, 7 minus 2 first. So I need to subtract these two polynomials and then subtract them from the first polynomial. All right, so let's just go ahead and drop this guy down for now. We're not dealing with him yet. And let's go ahead and work in our brackets. And take our 4x squared minus 3x plus 8 and go ahead and distribute our negative. So it's going to change all of these signs, so positive x squared, negative x, and negative 7. I'm going to work in my brackets to simplify that. So I'm going to combine like terms inside of there. I see a 4x squared and an x squared, so that's 5x squares. I have a negative 3x and a negative x, so that's negative 4x. And then I have an 8 and a negative 7, which would be a positive 1. Now I'm ready to distribute inside of this bracket. This is because I'm subtracting these two polynomials now. So it would be minus 5x squared minus a negative 4, which would be plus 4, and minus a positive 1. So combine your like terms. And I want to write this in standard form, so I put the x squares first, so negative 6x squared. X's come next, so 8x. And numbers come last, negative 3 and negative 1 make negative 4 for my final answer. Okay, hopefully that was pretty straightforward to you. Don't confuse combining polynomials with simplifying powers, right? Something like this is different than negative 6x squared times 8x times 4. Those are all multiplied. These are addition and subtraction. All right, so on this one, from the section before, you'd multiply all the numbers and you'd take the exponents and you'd figure out how many are being multiplied and whatnot. But here we're just combining like terms, so don't get those confused.